Bismillahirrahmanirrahim. Assalamu alaikum viewers, welcome to my channel, and in today's video we'll try to learn how to solve the first degree ordinary exact differential equations. So over here, in order to understand the concept of your exact differential equation, what exactly it is, for that purpose I've decided to pick up a bivariate function, and I just call it like this. Okay, so if this function is said to be this function is said to be totally differentiable only if its partial derivative with respect to x and with respect to y, both of them, if they exist, then you will say that this function is totally differentiable or fully differentiable, otherwise not. So a total differential equation of this function is expressed in this way. As I've said that I've expressed my bivariate function by means of z. So I will write my exact differential equation of this function f like this. Now, as the partial derivative with respect to x exists as well as the partial derivative with respect to y, both of them exist. So you are going to write them like this. I'm sorry, it's y, and this is d of x, this is d of y. Okay, so this is said to be the total differential equation. Also, it is called exact differential equation. Okay, you can also use a notation here like this. The partial derivatives are also expressed like this. So we have the variety of expression anyhow. Also, we can express the partial derivative of f with respect to x like this, and the partial derivative of f with respect to y like this. Okay, so this is d of z, and also you can express dz like d of f. So there are several ways of expression. Okay, so this is it. I'm going to close it in a box for my a's. Okay, this is what you call total or exact differential equation. Okay. Now, if I say that I'm having a differential equation of a type in general like this, if I'm having a differential equation of this type, the question might comes in mind, perhaps this function m and function n could be the partial derivative with respect to x and partial derivative with respect to y. If I just try to compare this equation by means with this, that I've just enclosed in a box. So if I just assume that this could be f of x, this could be f of y, so is this really an exact differential equation or not? So we have to make a check over here. So what is that check? We know that while studying the partial differentiability, we know that if we just try to find out the derivative of f of x with respect to y, whatever the answer comes, it will be exactly equal to the partial derivative of f of y with respect to x. Okay, you can also express this thing in this way. This was the f of x that I have differentiated with respect to y, so this is f xy, and if this one is f of yx. Okay, because this subscript represents that you have derivated this function with respect to x afterwards and with respect to y first. That's what it means. Okay, they're just telling you the order of the differentiability. So if these two derivatives are same, like if we just differentiate this m, which is f of x with respect to y, and this n, which is f of y with respect to x, then both answers comes out to be same. But if they are same, then you say that yes, this function is, this equation is exact differential equation. And if they are not same, like if they are not same, then that is said to be a non-exact differential equation that you are later going to learn how to reduce it in the exact form afterwards. It's not the part of this video. So once when you will just make this confirm that the differential equation is exact in nature, and what is the process of finding out its solution. Okay, so for that purpose, what you do, you know that this is this thing. I'm just trying to put down here the hierarchy. Okay, so that's what exactly it is, and I can simply write down here m as well for my a's. So it's just a way of expression. What I'm going to do, I'm going to pick up this m function, which is exactly this. Then I will integrate in the first step. I will integrate this thing with respect to my x, okay, just to find out my f. So once when I will integrate it with respect to x, I'm going to have some answer here plus some constant, okay, and that constant is expressed like this, okay, because you know that if you're having some term which is expressed in y and you are just taking out its derivative with respect to x, you're definitely going to get 0 here. So that's why you say that whatever the constant comes, that is the function with respect to y, okay, so that's how you just do it. So this thing is actually your f of x, y. You're going to get a function back, okay, so you just call it equation number 1, okay, and after that, once when you get your f, which is exactly this, you're later going to differentiate in the next step. You're going to differentiate this equation with respect to y, okay, this is it. So these are simply the general steps that you have to keep in mind, okay, and you just differentiate this thing, you're going to get some h prime y, okay, and we know that this is actually our n, all right, we know that this f of y, or this thing, is our n, so it means this is our n, all right. Okay, now in order to get your h prime y, you just shift this thing over here and we are going to get our h prime, okay. Okay, so once when you get the answer of your h prime, now as we need to find our h here in order to get the function, what we do, we are going to integrate this equation with respect to our y, okay. So once when you just integrate this stuff with respect to y, okay, you are going to get some answer, and that is your this, okay. So whatever the answer you're going to get, let me just say that the answer comes out to be a, it's just in general. So whatever the answer you're going to get of h of y, you will just substitute over here and you will get your f, okay. So once when you substitute this h of y value in your equation 1, we will come to get our function value, which is the solution of the exact differential equation. So okay, and that is definitely some constant. So this is it, okay. So this is the general strategy that I just try to put down here. Now we are going to, and keep this thing in mind that it comprises 3 steps. First of all, you just integrate this m part with respect to x. Okay, you get this equation, and then whatever the equation you get, you will derivate it with respect to your y. You will get your h prime y, compare it with your equation n. Okay, this one, h prime y, whatever the answer you get, you will just integrate that answer with respect to your y. You will get your h of y, substitute it back in your equation number 1, you will get the function. This is the strategy. Now let us pick up one example and just try to apply all these steps over there in order to get our f. Okay, so let's see the example. Okay people, so this is the example here, and let's try to solve it out. And in general, you can see that the exact differential equation is expressed in this form. Okay, so you can see that if I just try to compare my question with this general form of exact differential equation, we say that our m is 3x squared y squared minus y cubed plus 2x, and my n is 2x cubed y minus 3xy squared plus 1. Alright, and we have just studied a few moments back that this is our df upon x. Okay, the partial derivative of function with respect to x, and this is the partial derivative of our function with respect to y. Okay, so in easy words, this is fx, this is fy. Okay, so the variable with respect to which we have differentiated partially is written over here in the subscript. You can observe here. Okay, so this is it. So now in order to check is it really exact or not, what we do, we are going to differentiate this fx, okay, with respect to y. So whenever we just try to differentiate any expression with respect to y, the other variable which is so involved there going to behave with a constant. Okay, so over here it seems to be 2y becomes 6x squared y. Okay, because you see that 3x squared is behaving as a constant here, so we are simply differentiating y squared here with respect to our y. Okay, so it's 2y, so once when it gets multiplied with this thing, gives me this. Okay, this is my 3y squared, and this is 0 obviously because it is behaving as a constant here. This is the answer. Now over here what we do, let me just make a demarcation nicely. Now I'm going to differentiate my fy with respect to x. Okay, so you can also express this thing like this. Okay, so now I'm going to differentiate this thing with respect to my x. This time y is going to behave with a constant here, so it is now 2y is constant, so we are going to differentiate just x cubed here. It gives me 3x squared. This is the answer, minus, and now this y squared and this 3 is behaving as a constant, so simply this thing is here x, so on derivative it gives me simply 1, so that's it, and the derivative of 1 is 0. So you can see that both these answers are same. Okay, so you can see that this is equals to this, so this thing confirms that this is an exact differential equation. Now once this thing is confirmed, now we are going to find out the solution of this exact differential equation. Now we are going to follow all those 3 steps one by one. So we know that this is our m, so we are going to differentiate m with respect to our x. Okay, so now let's apply the steps. Step number 1. Okay, so this was our m, so we are going to integrate it with respect to our x. Okay, so we're simply going to get f here. We can simply write f or f, x, y, whatever you want. So, okay. So as I am integrating with respect to x, this is going to behave with a constant, of course. That's it. So I'm having now x cubed upon 3, 3y squared, x cubed upon 3 minus xy cubed plus 2x squared upon 2. Alright, plus some constant, and that constant is my this. Okay, this and this gets cancelled. What I'm having here is x cubed y squared minus xy cubed plus h of y. Okay, and this is my f, and this is my equation number 1. Alright, now what I have to do, this is my function, but this is not complete answer. I have to find this value. So for that purpose, we are going to move to step number 2, and we are going to differentiate this entire equation number 1 with respect to our y partially. Alright, okay, so partially differentiating both sides with respect to our this. Something, that's what exactly happening here. So here x cubed is behaving as a constant, so you can write it like this. You might be thinking that the lady is getting mad mentioning every single primary step, but what should I do? It's my habit. Okay, can't go against it. So this is now 2y x cubed. Alright, this is minus 3y squared x plus h dash prime y. Alright, so this is exactly your fy, and we have just started here that fy is our n. Okay, so this is our n, and the value of n is this. Okay, so now we are going to write down the value of n here. 2y x cubed minus 3y squared x plus this is equals to the value of n is 2x cubed y minus 3xy squared plus 1. Okay, so you see this and this gets cancelled, and we are simply getting h prime y answer, which is 1. Okay, so this is it. Now we have to find h of y. So now we are going to integrate this equation with respect to y. Okay, come to the step number 3. So what we are going to do now, integrating this thing with respect to our y. Okay, so this thing shows we are now having h y equals to y plus some constant. Alright, we just call it c1. Alright, now this is the answer, and we are going to now substitute this answer in our equation number 1. So, equation 1, the function that we are seeking, which is the solution, is x cubed y squared minus xy cubed plus y plus some constant. Okay, and this is equals to some constant c2. Alright, so now we are determined to find the value of our constant as well. So once when you move the C1 over here, it gets subtracted from C2, so definitely you're going to get some constant answer. You can write down simply C here. Now, over here it is provided that for every x equals to minus 2, the value of y is 1, okay? So for x equals to minus 2, the value of y is 1 here. So if we just substitute the value of our at the place of our y, x, we are having minus 2. At the place of y, we are having 1. This is minus a. Okay, so this minus 5. The value of c is minus 5. So this thing shows that the value of our function is this thing equals to minus 5. Alright? I just forgot to write here x squared. That's my mistake. I'm sorry for that. My grave apologies. So this is my equation number 1 involving x squared here. So we have to differentiate x squared over here as well with respect to our y. So that is going to give me 0. It's not going to be mentioned here. So that's correct, and that's entirely fine. The remaining step is fine. So this was our major fault. Okay, now it's helped out entirely. Okay, now we are going to put our values here. So how about if I just write my 2x squared in the beginning? Okay, now it's fine. So it's 4. Okay. So minus 5 plus 4, so it's giving me minus 1. Okay, the value of c is therefore minus 1. So once when I just substitute the value of c over here, that's minus 1, it moves over here, it becomes plus 1. So my equation x cubed y squared minus xy cubed plus x squared plus y equals to minus 1, so I will move it over here, and this is it. So this is the function of this exact differential equation. So this is entirely the process. Okay, so I hope now it is clear to your mind. So, and that's all for today. So if you find this video helpful, I humbly request you to subscribe my channel, hit on the like, and share this video as much as you want with your friends and other learners. And inshallah, I'll see you soon with another video related to your first order ODE. Take good care of yourself. Allah Hafiz.